Welcome to the MS SQL Tips webcast, high availability, disaster recovery, low-cost storage in virtual and cloud environments, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast host. Joining me today is Denny Cherry and Dave Birmingham, who will discuss what you need to know about protecting your SQL Server data for virtual and cloud environments. Before we get started, if you have questions, you can submit them at any time during the webcast by entering your question in the question area in your presentation controls. We'll try to answer as many questions as possible during today's webcast. If you have any technical issues with sound or screen quality, also use the question area to let us know. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to mssqltips.com and sign up for our newsletter, read tips, download white papers, watch archived videos, and post your SQL Server questions and be answered by our community members. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with the links. So at this time, I'm going to turn things over to Denny, and he can begin.
Thank you, Greg. Good morning, everyone, or good afternoon, depending on where you happen to be. It's still morning here in California. Thank you all for coming. I appreciate you coming spend an hour or so with me today. If there's any questions that I don't get answered during the presentation today, my contact info is here on the screen. It's on the next slide as well. So feel free to shoot me an email. I'm more than happy to respond to emails, get any questions answered. Now, if there's anything that I don't know the answer to, mainly because it's sales related, I'll just kick that straight over to the folks at SIOS and let them answer it as well. And I believe there's an email address for SIOS at the end of the deck if there's any questions for them that we don't get answered during the session as well. Excuse me. So a little bit about me real fast, and then we'll get on to the more interesting information. So I am the owner and principal consultant for Denny Cherry and Associates Consulting, based here in beautiful San Diego, California. I've worked on about 6 or 8 books now, including Securing SQL Server, which is my solo project, which is the blue one there in the middle. In fact, the 3rd edition of that book should be coming out any day now. It is no longer my fault that it hasn't come out. I've officially submitted all the stuff that I need to submit to get that done. So they'll be sending that to the press and getting that shipping out to all the pre-orders shortly, hopefully. I've written a variety of magazine articles for various websites, including and physical magazines, including TechNet Magazine, SQL Server Magazine, WinIT Pro, TechTarget, a few others, names I can't remember off the top of my head. I've been a Microsoft MVP for, I believe, the last 7 years for the SQL Server product. I've been a Microsoft Certified Master for SQL Server 2008, and I am also a VMware vExpert on top of that. What are our high availability options? We have a few of them available to us when we're working in the cloud, the quote-unquote cloud. And some of them are better than others, and they pretty much all have an issue, at least one. So let's walk through them and look at what those issues are. So this is going to be different from some of the normal presentations I do, where I talk about how good things are and what all the benefits are of everything. Instead, we're going to have a slam fest for the next 45 minutes on why things don't work the way we want them to, because I think that's more fun and can actually be more informative than saying, hey, these are all the things that do work. So we've got, as far as our options go, for HA, we've got mirroring, good old database mirroring. We've had it since 2005. We love it. Works great. Always on failover clustering. So keep in mind when we talk about always on, there are actually 2 features underneath that umbrella: failover clustering and, conveniently, the next slide, or next bullet point, availability groups. So those are both available as high availability options within your SQL Server environment for your high availability requirements within these platforms. So what are those DR options that are available to us? Well, they're actually going to look fairly similar, fairly familiar. Log shipping, database mirroring, failover clustering, and availability groups. So you'll notice I didn't put log shipping on my high availability list, and it could probably go there for some people. The reason I didn't put it there is because I believe that HA requires automatic failover, because we're looking for high availability, not just keeping the system up. So because of that, log shipping is not on there, because I would never actually set up log shipping with automated failover. Could you? Of course. Should you? No, because you're going to have data loss in the event of a log shipping failover, and it's going to be a royal pain to set it up to do it automatically, and there's no way to guarantee you're not going to have data loss in those situations. So, what are the issues that I see with log shipping when it comes to setting up in a cloud environment? Well, the first one is this log shipping. It's a pain to deal with. Now, the nice thing about log shipping is it's been around forever and it's rock solid. But there's no automated failover, so there's no clean way to get things across. You're always in an asynchronous mode. There's no such thing as synchronous. So there's always data loss. So we need to work with the business and figure out what levels of data loss are considered acceptable so that we can make sure that we're not losing too much data when we do that failover. That's why I only want this going to DR. I only want some sort of major event to be driving us to DR. Now, how do you set up DR in the cloud? I mean, the cloud is this nebulous thing. So you may not be able to do really any sort of control over where things are. That's the concept of the cloud. The reality of the cloud is you do actually have a decent amount of control over where things go. You may not know what rack or what row within a data center your stuff is physically located in when it's in the cloud. But that said, you do have complete control over what data center your stuff goes in when you're working in the cloud. No matter which provider you're dealing with, and I'm going to focus on Rackspace, Amazon, and Azure, no matter which one of those guys you pick, you know exactly which data center you're putting your services in, because it says so right there on the portal. So if I go in to, I'll use the Azure portal here as an example. If I go into the Azure portal and I go to create a new virtual machine, I tell it exactly which data center I want to put it in, because I've defined the network on that data, within that data center, and I've put an IP range on it. I'm going to say, I want you to put this VM in my network on, in the US West data center, which is the one in Fresno, I believe. So I create it in that data center, it spins up, and it starts working for me. So I can actually do stuff, and I know what data center it's in. So if I need DR, I've got a couple of options at that point. I can either go and put my DR environment in US Central, US East, or even in Europe if I really want to go crazy and put it in another continent. Or I could put it into another cloud provider. So if I'm doing production in Azure, I could, for example, do my disaster recovery over in Amazon AWS. And I've actually got a couple of clients that I'm working with right now that are doing that exact configuration, because they want to make sure that no matter what, they don't have any sort of reliance on any single cloud provider. So they've gone ahead and done, all right, let's do production here, and we'll do DR way over here, so that if something goes wrong and an entire cloud provider is taken out, maybe somebody hacks DNS and shuts the entire Azure farm down somehow. I don't even know if that would be possible, but it's probably a bad example. If they were to do that, we still want to be up, so let's put our DR site over in Amazon. So that way, if Azure goes down, Amazon is probably still going to be up, and we can keep our systems up and online that way. All right, so enough sidetracking. So back to log shipping. When dealing with the native log shipping, the error messages are less than helpful when setting it up and when working with it. If you've ever worked with the native log shipping feature in SQL Server, it's all done through some EXEs that actually do the backing up and the restoring and the moving of files and stuff. And because they're EXEs being run through SQL Agent, all of the error messages are .NET stack dumps that are thrown into the SQL Agent job step history, and they don't fit. So we end up with half the error message getting logged there. So when you need to start debugging, you need to go run the tools manually with all the appropriate parameters. And it gets to be an absolute chore to try to get the error messages up and on the screen and actually see what's going on. And because they're .NET messages, it's just throwing the last error that it sees. It's not necessarily giving you all the SQL errors. So it can actually make it very hard to troubleshoot on top of that, as you're not actually seeing maybe what the actual problem is. So you've got to fire up other tools like Profiler to try to see what's actually going on and what messages are actually being thrown when they're being thrown to see kind of what's happening. So log shipping actually requires more than duplicate storage. So it says duplicate storage here. So it requires duplicate storage as far as the databases themselves are concerned, but you've also got to keep into account, you've got to now double your backup storage as well. Because the way log shipping works is it backs up your production databases, copies those production backups to the DR server, and then restores them. So while it's doing that, you require storage for the database, storage for the backups, and then on the DR site, you need all that same space again. So if you've got a 0.5 terabyte database in production, you've probably got 1 terabyte of storage, give or take, depending on how big the logs are. That means you need another 1.5 terabyte of storage over in DR. So your storage costs are going to get very, very expensive very quickly. And of course, you have to have a full or bulk logged recovery model. Because if you're going to do log shipping, you have to maintain a transaction log. Simple recovery model simply doesn't maintain that transaction log, so it's not going to be usable for log shipping. So database mirroring. What are the issues we have with database mirroring? Well, biggest one, it's been deprecated. It was marked as deprecated back in SQL Server 2012. It's still available in SQL Server 2014. It may still be available in SQL Server v.next, whatever that is, whatever that's going to be called. I don't personally believe it's going to be. I'm expecting it to be gone as of v.next and there to be some sort of replacement. There's no guarantees, obviously. Another thing I absolutely hate about database mirroring is it only goes across 2 nodes. So I remember back in the day when SQL Server 2005 was not yet released, and it was an early beta still. I don't even think it was a public beta at the time. I was at a presentation, one of the movie theater presentations that Microsoft used to do when the MSDN team would go to all the various data centers. And one of the things that we asked was, will database mirroring support multiple replicas, kind of like availability groups does today? And the answer back then was yes, it should. Well, obviously, that never materialized. So that kind of made me very unhappy with the whole database mirroring product to begin with. But I understood kind of why they ended up with only this 2-node version. I wish they had been able to go bigger than that. But it is what it is, and it is only 2 nodes. So you get a production copy, and then you get a mirror, and that's it. That's all you get. So if you need that 3rd copy for something, you can't have that. And even if you could, database mirroring based on this architecture is read-only. So there is no, copy to run reports on. There is no copy to take backups on, stuff like that. So you've got those problems there. Other big problem with database mirroring, and this was seen as a benefit early on, but once we got actual applications started relying on it, is this became a big issue. Is your databases all fail over independently of each other. So if you need 3 databases to always be on the same server at the same time, now you've got a potential problem, because that's just not going to work. Because there is no database failover there where the databases are guaranteed to be on the same server, because they do fail over as independent units from each other. This is actually a problem for one of my clients. One of my clients actually has, I think, 7 or 8 databases as part of their application, and the application requires them to all be on one piece of hardware, or one instance, effectively, for the application to work correctly. So they're actually hosted over at AWS, and still using database mirroring today. And they've been in AWS for 4 years, 3 years, something like that. So they've worked the kinks out of this setup in their configuration already. but they have, especially right at the beginning, they had a lot of problems because one database would fail over and the other ones would stay put, and the application would then break because the databases wouldn't know where they were. This obviously caused quite a bit of problems for the application. So database mirroring can work if your app fits a lot of categories. Then you can make it work for you. Another annoyance with database mirroring is it requires that you change the application string to make database mirroring work successfully. Log shipping does this as well. You've got to tell it, hey, here's this other server. So in log shipping, after failover, you've either got to go play with DNS or you've got to go and modify the connection string, go, hey, go talk to my new server after failover. With database mirroring, what you actually do is you've got to go into the application and tell it, hey, here is this failover partner, I believe is the parameter name, and tell it, hey, I want you to, in the event that the production server is not alive, go check this other server. And that allows it to fail over to the second app automatically. So that does require the SQL 2005 or newer drivers, which for the most part shouldn't be an issue anymore. But that is still a change that you have to make, whereas excuse me, some of the things like failover clustering and availability groups don't necessarily have those downsides. With those things, you can just go, hey, here's the name you connect to, and just go connect to it. So if you did need asynchronous database mirroring, so for example, if you were going to disaster recovery using database mirroring, that would require the enterprise edition of SQL Server. So you can't do that with standard edition. So when you would need this is, for example, if you were doing your production site in the US West data center in Azure, then you put your disaster recovery site in the US East or US Central regions of Azure. Those are significantly further away. US East is in, I want to say, Austin, Texas. Sorry, US Central is in Austin, Texas. US East, I believe, is in Virginia. I'm thinking Richmond. So either one of those sites are going to be way too far away from the west coast of California to actually do synchronous database mirroring to them from US West. So you'd have to have asynchronous to get that far. So that would then require the enterprise edition of SQL Server. Mirroring does still require full recovery model. So you've got to have that full transaction log. So this has actually been a problem for a client I literally was working with last night. They're using database mirroring to go between their production and DR sites. Production is in Mesa, Arizona. DR is somewhere in Utah, so relatively close. So we're actually doing synchronous, which is fine, so we're on standard edition. But one of their databases in application servers is chewing through transaction log space. And when in the process of setting up the database mirroring, that just flipping it to full, taking the full backup and the log backup and copying those to the remote site, it chewed through something like 150 gigs of transactions. So when I got database mirroring up and it started feeding those transactions, it actually couldn't feed the transactions fast enough across their WAN link for this one database. So the database actually went down during the middle of the day yesterday. So got it restarted, got it back up and running. It went down because the log became full because it couldn't ship the transactions fast enough. So I actually got the database back up last night and just put it back in simple recovery and just told them, look, we're going to have to try this again over a weekend when there's going to be less transactions running through this thing, hopefully, because we've got to be in full recovery. So getting the database mirroring, it can work, but you've got to know what your bandwidth limitations are and understand how fast it's going to be able to move that data through. So always on failover clustering. So this gets very hard to do in a cloud environment or even in a local environment when you've got local disk because you've got this requirement for shared storage. That's just a requirement of always on failover clustering. And if you're trying to do this in a cloud environment, until you look at the SIOS DataKeeper product, which Dave will be showing you a demo of when I'm done with my slides in a few minutes here. It's very, very hard to get this up and running because you don't have a way to replicate data. And by very, very hard, I mean it's pretty much impossible to do without some sort of storage-based replication product like the SIOS DataKeeper to move that data from one site to another. If you want to do failover clustering, multi-site configurations in cloud or on-prem can be complex to do. You've got to make sure you've got everything set up right from the beginning. And by everything, we're not just talking about that one failover cluster in SQL Server. You've got Active Directory stuff you've got to deal with. You've got to make sure you've got your networking stuff set up correctly, because there's a whole bunch of networking pieces that have to play correctly. You've got to make sure Kerberos is set up correctly so that you can get your failover between sites done and replicated out. You've got to make sure your drivers are up to date so that you can do the multi-subnet failover support, because you want to be able to failover as quickly as possible from one site to another, because you've got to be able to do multi-subnet failover, especially if you're in the cloud. They're not going to support stretch VLANs going from one site to another and stuff like that. So there's all sorts of caveats to getting FCIs set up correctly. Now that said, FCI is probably going to be your best bet in a lot of Azure environments or a lot of cloud environments. So if you're on-prem, storage-based replication is not going to be included typically in the cost of the array. Some of the smaller array vendors are including that as part of their cost now of the package. So even if they don't include it today, as they're working on it, they may toss that in later as they get it done. But when you look at the bigger array vendors, they're not necessarily going to include that cost in the array, and it can be a very costly purchase to get that in. If you're on-prem, I don't know why we have brackets on there. I must have typoed something. Array-based storage replication is going to be very complex to get set up sometimes. Depends on the vendor as to how hard this is going to be to do. I know a lot of them are very complex. I've spent days working through the process. I was doing an engagement for one client where I was setting up site-to-site replication between two different arrays, and the documentation from the vendor was a three-page checklist. But I knew that their documentation didn't work, so I contacted a friend of mine who also had that array and had done this exact same process. And I asked him for his checklist. Well, his checklist was like 7 or 9 pages, and his worked. But it's a very long, complex process to get this whole thing done. So you've got to make sure that you've got all this documentation and that you know how to get all this stuff set up if you're going to be doing site-to-site, multi-site failover clustering. So if you're in a SQL 2012 environment, which, as we know, the majority of people are, and you want to do a multi-subnet failover cluster, that's actually an enterprise-only feature in SQL Server 2012. So in 2014, that becomes a standard edition feature, which is good. But for some reason, back in SQL 2012, they made multi-subnet failover an enterprise-only feature. So if you needed to do multi-subnet failover, you had to have the enterprise edition, even if you wanted to just do it with a 2-node cluster, which was very, very annoying. So we do have a requirement with failover clustering for Active Directory. So this is actually, throw a monkey wrench in a lot of clients' high availability configurations when they get in Azure or AWS or even Rackspace. They want the HA that comes with traditional failover clustering, but they just need to throw 2 web servers up there and a database server, and they don't want to deal with Active Directory. But if you want this level of availability, you've got to have this Active Directory component. So suddenly this is adding a lot more work into the setup than maybe they were thinking of. And I've done this for a couple of different clients now. Literally last week I did it for 2 different clients where I had to build complete Active Directory environments and then set up the failover clusters and get the web servers up and running so they could load their websites onto them so it could start their migration process. And it just adds more complexity to the entire project. Now, if you've got an Active Directory environment today on-prem, you can simply just extend that out to the cloud, but you still got to build those DCs, get DNS up and running on them. There's a whole bunch of pieces that you've got to actually get set up. And it can be a lot of work. As long as you know it's coming, that's not that big a deal. But if you're unaware that you're going to have, this additional workload to do, that can be very scary sometimes. So always-on availability groups. Everybody loves always-on availability groups. It's the new shiny feature introduced in SQL Server 2012, and it got even shinier in SQL Server 2014. But it ain't great. There are some issues with it. The first one is to buy it and to use it, you've got to go get a big pile of money and put it in a bag and hand it to Microsoft. And you've got to do that for every 2012 or 2014 box you want to deploy with availability groups on it, because it's Enterprise Edition only. So if you want an 8-node configuration of always-on availability groups, you've got to license 4 of those boxes. So that's 4 big bags of money you've got to hand over to Microsoft. So you've got to be very aware of licensing and how the licensing works in SQL Server 2012 and 2014 to understand how much availability groups is going to cost you. The good news is we've got things like volume licensing and enterprise agreements that are going to help save you some money, but we are still talking easily 6 figures just to get into an availability groups environment. One of my clients is actually in the process of upgrading from SQL 2008 R2 to 2014 right now, and they've already got the infrastructure, they've got the hardware, they've got the Windows boxes, and they've got the SQL licenses. But now they're talking about spinning up a second physical data center and doing data and figuring out what they're going to do for that site-to-site stuff. And they're talking about always-on availability groups. And I'm like, okay, that's awesome. Love the idea. Here's the price tag. Because they want to do everything. They want readable secondaries. They want to offload backups to a second server. They want to do all the cool stuff you can do. Like, yeah, none of that's free. Here's that. Here's the bag. Go put some money in it, and we'll send that to Microsoft, and you can start doing this sort of stuff. So there's all sorts of little caveats you've got to keep in mind. There's a lot of checklist things that you can do with availability groups, and almost every single one of them is going to require writing a check to Microsoft or to your software vendor to get those features up and running. So availability groups does require Windows failover clustering. So if you haven't set it up and you've been curious about how it works, it does actually still require a Windows failover cluster underneath it. So if you're trying to use it because you want to get away from failover clustering, that's not going to actually help much, because you do have this failover cluster infrastructure that has to sit underneath it, and all the annoyances that go with that. I think the biggest one probably is the fact that when you're dealing with any sort of failover cluster, either Windows or SQL, you cannot upgrade the operating system, the Windows OS, of the boxes that are part of the cluster. So up till today, this is still the case, and I don't know if this is going to change. I know they've been offering to change this, but it hasn't happened yet. Is you still cannot upgrade the OS of the boxes that's running the Windows cluster. Someday we may get that, but not today. So whatever version of Windows you're running when you put your Windows cluster or your availability group cluster into production, that's the version of it that you're going to be running for pretty much ever at this point. So the reason I bring this up is because these availability group clusters end up being significantly wider than SQL clusters have typically been in the past. Most people, when they built SQL clusters, were building 2-node clusters. Well, the whole point with availability groups is that you could build a much wider cluster than that. So, in 2014, we can have 9 replicas, 1 primary and 8 secondaries. So that requires at least 9 nodes in your environment. Well, the odds of being able to take those 9 nodes down and migrate them to another cluster quickly and easily is very, very slim. It's going to require a large project and a lot of work and a lot of planning to do any sort of Windows upgrading on these availability group clusters. And that's just the reality of these things, is they're huge beasts within our data center. And getting that data moved from one site to another is very, very tricky as we try to do these Windows upgrades. Because you basically got to take the entire environment down, migrate the production database to whatever the new platform is, and then reset up the availability group. So we could be talking a significant amount of downtime to make this happen. So that's going to be very, very hard to get approved on an application where you're spending a lot of money and a lot of energy to keep that thing up and running, 3, 4, 5 nines. So availability groups does have some limits as to the number of supported databases that you can put in it. So today, in 2012 and 2014, our support limitations are 10 availability groups per instance with 10 databases per availability group. So for those of you who are good at math, 10 times 10 is 100 databases per instance in always-on availability groups. So that can be an issue for a lot of people. If you've got a server with a lot of databases on it and you can't separate them, you may have a problem. I'm working with a client right now, actually, where they were thinking about availability groups, but they've got 300 and some odd databases on their instance. So obviously availability groups suddenly is not going to work. So we've had to fail back to using failover clustering to get everything up and running for them. Because we're using failover clustering, this means we require Active Directory. So we've got all those Active Directory requirements there as well. Like database mirroring and log shipping, we need full recovery. Actually, with availability groups, we can't even use bulk logged. We have to have full recovery. So this is one of the nice things about failover clustering that if we did a SQL Server failover cluster, compared to an availability group. The failover cluster, you'll remember back on that previous slide, did not have a requirement for full recovery, but the availability group does. And that's because the availability group is using a TDS stream, which is the language that the SQL Server databases speak. So it's using TDS to replicate the transaction log from one server to another. So that requires full recovery so that we can ship that transaction log from one site to another, We require duplicate storage. So we have to have enough storage to hold the database once on every server we want to put it on. So if we want a 4-node or 4 replica always-on availability group configuration, we need 4 times the storage. That's just the way availability groups work. Today, and as far as I know into the future, you only get 2 synchronous replicas. So you can have your primary, and then you can have 2 synchronous secondaries that you can replicate to. And that's it. Everything else is asynchronous. So if you're in one of these big 9 replica configurations, 7 of your replicas are asynchronous and could have data loss in the event of a failover. So this requires a lot of planning to figure out how we're going to set this up and make sure that everything that's going to do failover and be our high availability requirement is going to be HA, while still allowing our DR portions to be asynchronous and have data loss. So maybe we can put reporting on asynchronous and then DR on asynchronous, and that'll be good enough for our requirements. But if we need 3 or 4 copies that are synchronous for massive high availability requirements, that's not going to work so much in an always-on availability group configuration. So what are some differences between on-prem and Azure? So we all worked on-prem, I hope, at this point. There may be a few people that have only worked in the cloud, but I think those people are fairly rare still. So if we've worked on-prem and we're thinking about going to the cloud, what are those major roadblocks we're going to hit when we try to go up into Azure? So the first one, the biggest one, is there's no native support for always-on failover clustering. And the reason for this is there's no such thing as a shared disk in Azure. Now, yes, Azure is basically just running Hyper-V, but Microsoft has not given us any way, either through PowerShell or through the GUI, to create one VMDK, one virtual disk, on two virtual machines. So because of that, we cannot do failover clustering natively. Always-on availability groups and failover clustering both require configuring what's called an internal load balancer. So one of the annoyances of Azure is that through the GUI, there's no way to get a second IP address for a machine. So when you do set up an availability group or a failover cluster, when you set it up, it's going to use DHCP because that's all that's available in Azure. And when it uses DHCP, it's going to get that IP address for that NIC, or for that virtual NIC to bring up within the cluster, but it's going to be the same IP address that's already on the cluster. So that's kind of a problem. So you actually have to go reconfigure that, give it its own IP address as a static IP, and just remember not to deploy any machines using that IP address. And then once you've gotten to that point, you then need to go build this internal load balancer which points to that IP address so that the IP address can be talked to through this internal load balancer. And it's kind of a workaround that Microsoft's put in place so that availability groups and failover clustering can work in a production environment. Because without the internal load balancer, if you try to talk to that IP address that's running your availability group or your failover clustering, the IP address that's configured in failover clustering for either one of those configurations, you're just not going to be able to talk to it. So that's kind of a problem. So which of these problems can we solve with SIOS DataKeeper? So there's nothing we can do about the internal load balancer, and it does work. You just got to set it up. So it's there. But what we can solve with the SIOS DataKeeper product is in failover clustering, we can get rid of that requirement for SAN storage. So we can do this with local disk, either on-prem or in the cloud. So if we're on-prem, this means we don't have to have a SAN to get that high availability requirement that we want within our SQL Server environment. If we're in the cloud, if we're in Azure, we're in AWS, we're in Rackspace, we can set up our failover cluster using the storage that's provided by the cloud provider. We don't have to have them configure some special shared storage environment for us. So we can set up a failover cluster in Windows Azure. I did 3 of them this week. Not a problem. So you can get them up, you can get them running within this failover, within this cloud environment quickly and easily just by sticking the SIOS DataKeeper software on there and setting up that replication from one machine to another, which David is going to show us in a couple of minutes. So some benefits of SIOS DataKeeper. So obviously I like the product. I wouldn't be sitting here talking to you about it if I didn't. One of the really big things I like about it is this first bullet point right here. We've got a variable amount of compression available, so we can set the bandwidth savings versus CPU cost to meet the requirements of our specific environment. So if you've got plenty of CPU to burn, you got lots of CPU overhead on your box, and you've got a very small network pipe between sites for some reason, you can crank that CPU up by turning that replication up. You can compress your data and shoot it across the wire and get it across the wire with less data than you could before. Now, native SQL Server does not offer this in any of the native support options. All they're doing is one level of compression. You like it or you don't, it's going to get done. SIOS DataKeeper, we can replicate to as many nodes as we need to. So if you need a 6-node cluster, replicating data across it, you can do that with SIOS DataKeeper. You just replicate all 6, you replicate all your LUNs to all 6 nodes, and as many of those can be synchronous as you want or asynchronous. So if you've got 3 in the local site or 4 in the local site and 2 in a remote site, the DR site, you can do that. Fully supported with SIOS DataKeeper. It will replicate synchronously to as many nodes as you want. I've never run out of nodes to replicate to. So in all the configurations that I've done. So I don't actually know if there's an upper limit. If there is, I haven't found it yet. SIOS DataKeeper fully integrates with failover clustering. This is another great benefit. Literally, as you go through the wizard setting up the data replication, at the end of the wizard, it pops up a message box. We see that you have failover clustering installed. Would you like to register this shared disk with the failover cluster? You click yes, and you no longer need to go into failover clustering and add it as a shared disk. It already takes care of that for you. So now you just need to use the disk. That's all there is to it. Because we're doing everything at the storage level, not at the SQL Server level, this product is totally invisible to SQL Server. SQL Server has no idea it's running on the box, and it doesn't need to. All it knows is it's writing to a disk, and Windows has certified that that disk is a shared disk across multiple environments, across the multiple servers in the replica. So the SQL Server doesn't need to know what's going on under the covers there. So with that, I'm going to toss it over to Dave so he can do a quick demo for us and show us how the SIOS DataKeeper works.
Thanks, Denny. Let me give me a moment here to share my screen. All right, hopefully you're all seeing my screen here. If not, just holler, but you should be seeing it. So, quick demonstration. I want to show you first how easy it is to configure so you get a feel for how it's going to work in your environment. So I have the DataKeeper interface up and running, and this is simply software that's going to be installed on each of the nodes in your cluster. As Denny mentioned, it integrates with failover clustering. So one of the prerequisites, you're going to have a basic cluster configured. So I have that going in the background. You see I have this cluster with some nodes, 3 nodes in this particular cluster, primary, secondary, and DR. But if I look in the storage, you'll see there's no storage. So I have no shared disk configured. This is going to be what you'll see in Azure, or really any cloud environment that does not have a SAN. So I have that kind of going. And then I have DataKeeper, and I'm connected to the 3 servers in question, primary, secondary, and DR, each running DataKeeper. And I just want to show you, basically, this is your configuration. The initial configuration, you're going to create a job, and then it's a simple 3-step wizard that will allow you to create the mirror. So here is step 1. You choose the source of the mirror, the IP. This is the network where the replication traffic is going to travel, and then the volume you want to replicate. And then the next screen, you choose the target. Secondary server is good, and the IP is good, and the volume looks good. And then here are your options. Denny mentioned the 9 levels of compression, so you can choose the optimal balance between CPU utilization and compression. But quite honestly, the first 2 levels of compression are going to give you a pretty significant compression ratio with minimal CPU overhead. Go higher, you're going to burn more CPU, but your return on investment starts to dwindle as you get higher. So and this is adjustable after the fact, so you can tweak it to your to meet your needs best. And then the synchronous or asynchronous. So for local replication, we might choose synchronous to guarantee 100% the data is always 100% in sync. For longer distance replication, for disaster recovery, we would do asynchronous. And then finally, the maximum bandwidth is a simple bandwidth throttle. Think of it almost a poor man's quality of service. If you want to limit the amount of bandwidth that DataKeeper will consume at any given time, put an upper threshold, you can specify that here. Now, the one good use case for this is during the initial mirror creation process, we will consume pretty much as much bandwidth as you will give us up to a point to get that mirror in a mirroring state as quickly as possible. And that might flood your WAN if you have a limited WAN connection. So you could throttle it down maybe for the initial mirror creation process and then turn it back to unlimited so you're not artificially limiting the ability of the replication engine. So you pick your choices here, and that's it. You click Done. That's going to take the E drive of the primary server and start to replicate all the contents at the block level from the primary server to the secondary server. As you see at this pop-up, it recognizes this is part of a cluster, and it asks me if I want to create the cluster resource as well. I'll say yes, go ahead and create that cluster resource. And that's going to create the DataKeeper volume resource that we will use in the cluster. So if I jump back into Failover Cluster Manager, now you see in storage I have this DataKeeper volume E, which we just created, that was automatically registered. It's in available storage. If you're familiar with clustering, you know this is the location where all the disks reside before you use them in a cluster resource like SQL Server. Before you create your SQL cluster, all the disks will sit in available storage. At this point, this DataKeeper volume, it looks and feels and smells like a shared physical disk resource, but under the covers, it's actually a DataKeeper volume resource, and that's giving you the ability to create clusters without a shared disk. So we can actually, through Failover Cluster Manager, get information about the mirroring right here in the properties of that volume resource. We see the current source, the current target, the network we're using, the state, the mirror type, current state. It's still doing the initial synchronization. That will change to mirroring once that mirror reaches a mirroring state. So bottom line is, at this point, if I were building a SQL cluster, I would I put my SQL installation disk in, run setup, walk through the wizard to create a SQL cluster. At the point where SQL is looking for an available storage location, it will present the DataKeeper Volume E just as if it were a shared disk. So the user experience is exactly the same. And then the cluster is created, and you manage it like a regular cluster. You never have to go back to the DataKeeper interface because everything is done through Failover clustering. So much like a cooking show, I'm going to jump over here and pull this out of the oven. This is actually an Azure deployment that's currently running in US East. And I have two nodes. I have a primary SQL 1 and SQL 2. And you can see the SQL is actually running on SQL 1 at the moment. If I look at the details of the resources, you can see I have my typical resources, my SQL services. I have the name with the IP. As Denny mentioned, in Azure, you have to configure an internal load balancer. We won't go into the dirty details here, but there's some scripts you have to run to create the load balancer and to update the IP address so that the load balancer can communicate with it properly. But that's once that's configured, then once again you manage it like a regular cluster. So this will respond to outages. In Azure, there's really two types of outages. Really, any location, there's two types of outages, right? There's planned downtime and unplanned downtime. In Azure, they have something called fault domains and update domains. An update domain is basically the, well, both domains really are just different parts of the Azure infrastructure, so that if one node is in one domain and one update domain or one upgrade domain or fault domain, then and the other node is in a different upgrade domain, Azure will guarantee they never take down more than one upgrade domain at a time for planned maintenance. So by having the nodes in different upgrade domains, you can be sure that if they bring down one node for maintenance, your remaining node will come online automatically. It will fail over like a traditional cluster will fail over and continue to run. And fault domains are the same concept, but they're really for unexpected failures. If there's a problem within the infrastructure, it usually impacts a single fault domain, and the other different fault domain has totally independent power and networking, servers and storage and so forth. So that's what you really have to do as part of the configuration is get these nodes in different upgrade domains and fault domains. And then after that, you can of course you can manage it where you can move the resource as you see fit. So I can move this from SQL 1 to SQL 2. Under the covers, the DataKeeper volume is essentially reversing the direction of the mirror. So you see the volume is already online. So what that means is now all the writes that occur on SQL 2 will automatically be replicated back to SQL 1. But in reality, the user doesn't really, they might not even know because it's really just behaving just like a regular cluster. But instead, these volumes are additional volumes that are attached to each instance in Azure. And the same concept really applies for any cloud. So AWS, I think each cloud probably has a couple unique wrinkles about it, but we certainly have the expertise and the documentation to help you really with any cloud deployment that you're looking at. So definitely, if you have questions about your particular cloud, reach out to us and we'd be glad to get you the right information. Because there are some wrinkles, and like I said, with the internal load balancer in Azure and AWS, there's this thing called, secondary IP addresses have to be bound to the physical NICs in the configuration. So there's some things that if you're not aware of it, it could take you some time to figure out and get the right information. But we do it all the time, so we pretty much can get you straight right away, so you're not just wasting a lot of time. So I know, speaking of time, I think we're coming upon the top of the hour, so I want to make sure I leave these next 5 minutes to answer any questions. So I'm going to be quiet, and let's submit your questions on the Q&A tab, and Denny will answer any questions you have about clustering and clouds and any product-related questions that Denny wants to throw to me. I'll be glad to answer.
Okay, great. Thanks, Dave. And thanks, Denny. Yep, there's a few questions out there. So actually the first question, Denny, is related to the availability groups limitations. You mentioned there's 10 databases, 10 availability groups. Somebody mentioned that they have 11 databases in an availability group, and just wondering, is 10 a best practice, or can you kind of speak to that?
So 10 is the official supported limit. That's not to say more won't work, which it will, but 10 per availability group is the official limit that Microsoft supports and has tested to. So there's a big difference between tested to and works fine. Tested to just means that that's all they tested in their QA lab. So 11, yeah, it'll work just fine. But you can use it, but just keep in mind if you do try and call support, they may not be all that helpful for actually setting up for getting support.
Okay, great. The next question is related to DataKeeper, and the person is just wondering, is there an API or some way to do remote monitoring of DataKeeper?
So there's not much monitoring you actually have to do of DataKeeper itself. Dave, that's probably more of a question for you. Is there any way to monitor remotely if there's any lag in the replication in DataKeeper?
Yeah, I mean, DataKeeper has a couple things. So we have some perfmon counters that will show you things like the queue current length. So if you're doing asynchronous replication, the queue length is what you are would be interested in. If you are, and that also will give you mirror state. The other thing is everything we do is logged in the event log. So the system log and the application log will give you information about your current state of your mirror. So they're really the two locations that you would look to monitor DataKeeper. And of course the GUI, you can install the GUI on any system and connect remotely, and you can get a good visual indication of the current state of all your mirrors as well. So the GUI can install without any additional licenses on as many workstations as you like.
Okay. And actually, Denny, do you want to go to that last slide and then just kind of talk to that real quick before we take the next question?
Yeah, so actually this slide. So Dave, who did the demo today, has actually got a presentation on Windows 10 and clustering that he'll be presenting, which should be a really great presentation that you can register for right now if you go to that URL, and I'll leave that up while we do another question or two. That's going to be March 25th of this year, obviously, at 10 a.m. Pacific, 1 o'clock Eastern. So that should be a great session if you're looking forward to Windows 10 Server coming out, whatever Windows 10 Server is going to be called, when it actually launches. This is going to be a great introduction to some of the changes that are coming in the Windows 10 failover clustering, because I know there's a bunch of them coming. So I know I'm looking forward to this presentation that Dave's going to be giving.
Okay, great. Actually, the next question here is related to replication, and the person wanted to know, are there benefits of using software-based replication like DataKeeper versus SAN-based replication? You can kind of speak to that, both in the cloud, on-premise, hybrid, et cetera.
Yeah, so there's definitely benefits to using software-based storage replication versus hardware. The biggest one is typically money. Storage-based replication is going to cost you a small fortune if you're looking at your traditional big iron storage vendors. So when you're comparing that to the cost of SIOS to get your data replication through DataKeeper set up between two boxes, significant reduction in cost. The other nice thing is, as the DBAs, we can manage the storage replication through DataKeeper. You're not going to get SAN, control of the SAN or the storage array to set up storage-based replication or to manage or monitor storage-based replication. That's just pretty much not going to happen in any shop unless you happen to be in a small shop with an array where you're monitoring and managing everything yourself. So with the DataKeeper, on the DataKeeper side, you can do that from a DBA level because it's all installed on the Windows operating system, as you saw in Dave's demo. In the cloud, there is no other option. You don't have any sort of hardware-based storage replication, even if the environment is SAN-backed. We don't know how the Azure and AWS and Rackspace clouds are configured. They haven't really published too much about the hardware. I can say with pretty good certainty that they are not SAN-based, SAN-based environments. So that means that if you want to do storage replication and do some sort of failover clustering in any of these cloud environments, really your only option is to go with the to go with SIOS DataKeeper and get it up and running that way.
Okay, fantastic. Well, we're actually out of time. We're going to wrap things up. So I want to thank Denny and Dave for sharing all that great information. And also want to thank SIOS for sponsoring today's event. So please visit SIOS at us.sios.com to learn about all of their solutions for SQL Server. Also want to bring this up as well, the slide. Please join us for that Clustering 101 at the us.sios.com/2015-03-clustering 101. So you can sign up for that right now after this webcast. Once again, the webcast was recorded, and you'll receive a follow-up email with the links to view the archive. We'll have that either up later today or by early tomorrow. Also visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and I hope you all have a great day.